My name is Fabricio Campo. My topic is Venturi pipes. My purpose is to inform students on fluid mechanics and Venturi effects. My thesis is that by introducing the Venturi effect, it will aid students in learning that fluid laws. Fluid mechanics is one of the oldest areas of physics. This field has the greatest number of applications in everyday life, and scientific museums describe this phenomena, and this adds to my credibility. My thesis statement is that the working principles of the Venturi effect on the Venturi pipe will allow students to grasp difficult fluid laws better. My main points are the history of science on the Venturi effect, aquacultural ponds, and wind turbines. Giovanni Venturi reported that fluid flowing through constriction in a pipe drags a second fluid along with it from a second pipe. The result is that static pressure is lowest where fluid speed and pipe constriction are greatest. My supporting point is that atmospheric pressure will equal to the down pressure times the gravitational acceleration times the height of the liquid in vertical straws. And this just means that pressure in the straw is less than atmospheric pressure, which therefore pushes liquid up at the bottom of the straw. Where height of the liquid in the straw is maximum, the static pressure in the horizontal pipe is minimum. Static pressure is least at the narrowest point of the pipe. Daniel Bernoulli's book of hydrodynamica was published in 1738, and on it there's an equation that half of the density of the fluid times the velocity or speed squared would equal a constant, and by this equation we can infer that an increase in speed causes a decrease in atmospheric pressure, density of the fluid, and vice versa. When water speeds up, pressure decreases and bubble size gets bigger, vice versa. The movement of a fluid inside pipes traditionally used in transport and pumping systems can be described through fluid mechanics. It is possible to propose modifications in Venturi tubes to regulate aquaculture ponds. Flow speed and acceleration, the pressure and temperature of the fluid, and the output volume in the pipe can be controlled. This is done by understanding the mathematical effect on the behavior of the fluid. The geometry of Venturi tubes corresponds to two conic sections joined by a thin cylindrical tube. The speed of passing fluid increases, causing a drop in the local pressure. A pressure difference in a thin cylindrical joint can be done through a modified Venturi tube that allows the fluid to be oxygenated. A suction can be used to inject oxygen into the passing fluid. This is done by making a hole in the cylindrical joint. This is used in medical, environmental, and other areas, mining. In the case of aquaculture, it is used for tilapia rearing ponds. My main point and last point is that the power of generation efficiency of wind turbines will depend on the Venturi pipe. Drastic decrease when the wind direction is more than 90 degrees from the axis of the Venturi pipe can be observed when a vertical axis wind turbine that accepts wind in any direction and converts it into electrical energy, but the conversion efficiency is low. The wind is not evenly distributed. When the angle exceeds 120 degrees, the system does not generate electricity at all. The wind energy capture efficiency of a horizontal axis wind turbine is high, but when the wind direction changes, the jaw mechanism is needed to adjust the wind turbine, which has reached the best working condition. In Velox, a third wind turbine can capture wind from all directions without any jaw mechanism. This can be used for testing, but not in application, real world application. At a certain inlet area, the most important parameter which affects the envelopes is the Venturi diameter. This result shows that the wind speed in the Venturi section can be increased about 25% by increasing the diaphragm. My sources are the Journal of Physics and the book An Approach to the Venturi Effect by Historical Instruments. In conclusion, understanding a Venturi pipe is fundamental to fluid mechanics. Introduction to the Venturi effect can aid students in learning new fluid laws, and by learning about Venturi pipes, we prevent any misconception or notions that arose from incorrect presumptions of fluid mechanics. I hope you leave with an authenticated understanding of the subject matter. Thank you.